Hello everyone. After a long time I'm making a video. I was busy with some work. So we'll talk about CPU versus GPU today. So there are in total 3 points which actually differentiate CPU with GPU. Two of them are basically more practical and one is where theory comes into picture because some of you guys have asked me to be a little more into depth. So I thought I'll put some equations which works. So first thing about CPU. So CPU basically handles multiple types of data at the same time. If you're using an Excel sheet and at the same time you're playing a video onto the YouTube and everything else, like multiple processes at the same time, they're all different. All of them are actually handled by CPU. In case of GPU only takes care of graphics and nothing else. For example, if you're playing a game, so it specifically works when that particular game is on the screen. In the game, let's just say you are playing Counter-Strike or some game like shooting game. So one part of the GPU will take care of the background shift, the background colors, the way the anti-aliasing of the background elements, and the other part of the GPU will actually take care of the user, its movements, how smooth is it. So those parts are taken care by GPU. So GPU basically takes single type of data and uses it or processes it. But when it comes to CPU, it takes multiple types of data. Second part is, in CPU, there are lesser number of cores, but those cores are powerful. For example, in one CPU, if I have 4 cores, C1, C2, C3 and C4, all of them can be between like 2 to 3 gigahertz. So it comes down to, like, if it's 3 gigahertz, it comes down to 12 gigahertz of speed, let's just say, for example. But when it comes to GPU, the case is a little different. GPU has more cores. It has many cores, like in terms of 100, 200, it can be in terms of thousands also. But those cores are basically only 1 gigahertz, 0.8 gigahertz, 0.5 gigahertz. So there are every core is not that heavy or intensive or can process a lot, but there are so many cores that ultimately it parallel processes. It helps the data to parallel process and gives you a proper result in the proper time. So that is why GPU is very important. It can do parallel processing, but when it comes to CPU, it can only do sequential processing. Both can do individually, but this is better for graphics because you need parallel elements to be processed at the same time, and same equations will be used all the time. If you're playing a game and you're showing sky or something, same equations are going on all the time. There is no radical change. So that is why GPU comes into picture. Third point is basically the execution time. So execution time, tau t, is equal to 1 upon clock frequency. If the frequency is higher, execution time will be smaller. If the frequency of CPU, as I told you, 1 gigahertz, 8 gigahertz of processing, if it's faster, execution time will be smaller. Then multiplied by CPI. CPI basically means clock per instruction. So how many clocks do you need for that particular instruction to be executed will be multiplied. If you have more clocks for a particular instruction, the execution time will also increase at the same time. And then multiplied by IC, instruction count. How many instructions do you need to calculate in a particular amount of time? So all of these equations come into picture and tell you the execution time. Same thing happens in GPU as well, but this equation is been multiplied by number of cores you have. So that basically differentiates between CPU and GPU. So same thing, same execution time, same frequency, same CPI and same IC multiplied by number of cores. So this is how GPU is different from CPU, and I hope you have got what is the difference. If you have any questions, if you have any suggestions, you can let me know in the comment section, and thank you for watching.